Hey, good morning. Friday, April 25th. I hope I didn't get the date wrong. Right, Wednesday was Earth Day. That was the 22nd to 24th. Okay. Friday, April 24th. What I have for you, nine problems on the assignment of oxidation numbers. Each test and reviews like a specific thing. So what I'm going to do is hold up a piece of paper, let you write them down. Be careful writing the formulas because if you forget a number or put the wrong number, you're not going to be able to do it. But write the problem down, solve them, and then I'll have a review. I have five and then four. So there's nine problems that we'll do this morning. Okay. So here's the first set. Okay. Write them down. It's O3. Fe positive 2 is an ion. Fe positive 3 is an ion. I think I said that backwards. I did. There are two iron ions. One is positive 2, one is positive 3. They should be fairly easy. Then NH3, and then the hardest one on this page is that last one. It's Cu, copper, parentheses, NO3, subscript 2. So it's O3, Fe positive 3, Fe positive 2, NH3, CO3 2. Pause. Try them your best. Write the answer for each one down this row here. Okay? Write the answers down there. For each individual atom, one. Like there's three H's, so you're writing the charge of one H. So you're not going to write positive 3. You're going to figure out what one H is and write that. Same with the O3. You're going to write down what one O is. And just remember the rules. It's actually really simple. It doesn't even matter that there's three. Maybe you'll figure that out by what I said. But if not, I'll give you the answers once you finish. So press pause, solve them, and then restart. All right, here we go. Solution process. Okay. Hopefully, at this point, you've unpaused. If you didn't unpause, you wouldn't be hearing me right now, anyhow. So it doesn't matter. Okay. So O3, it's by itself, it's an element, there's no charge. It has to add to zero. So all three of them are zero. So your answer would be O3, oxygen. The oxidation number is zero. All right. I know it doesn't seem like even worth asking you a question about it, but believe me, when we go down to track the changes in oxidation numbers, you're going to need that. Okay. You're going to need to know that it's zero. Second one, I'm going to put both of them up there. The Fe plus 3 and the Fe plus 2. These are the easiest ones. All right. Where Fe is plus 3, remember, the oxidation number has to be the charge or sum to the charge if a polyatomic ion. So this is plus 3. This is plus 2. All right. Those two don't pose a difficulty. I think NH3 I did yesterday. NH3. Now, going back to my rules, right? Binary ionic compound. This is not a binary ionic compound. You do not have a rule for N. We would only have a rule for N as a binary ionic compound if N would be the second one and we can use the IDE. This is not the case here. So we have to use the rule for H. And I know the second one is usually negative, but in this case, remember, it's positive. That means N here is going to be negative 3. So N equals, which order did I write it? N equals negative 3. H equals positive 1. Okay? Questions for those? Okay, got that? All right. The last one is polyatomic ion. Actually, I'm going to throw one additional in there. I'm going to kind of explain it. I think you'll get it because it's going to help you with the last one. It's related to this NH3. I'm going to do the NH2 negative ion. I believe it's called amide. but amide or amide? No, amide, I believe it is. I don't know. Okay, let's say I have this ion. This ion exists. I know it's not in your reference tables, but it's a reasonably common ion. NH2 negative. It's a polyatomic ion. So now when we add NH2, it has to equal -1 because this ion itself, right, has to be negative because of its charge. It has to be a -1. Well, I'm going to turn on the other light. Okay. That ion is a -1. So we're going to use our same rules, right? H is going to be +1, okay? But there's two H's. Overall, it has to be negative. So the N actually still is -3. -3 and 2 positive 1s is -1 overall. Now, why did I do that with you? Because I want to discuss this last one, okay? Let's let you look at that for a second and I'll erase it. Or you can pause and look at it as long as you like. Okay, this last one, Cu parentheses NO3, close the parentheses 2. Okay? Now, you only have one active rule here, right? We're going to solve for Cu. I wrote that too big. I'm just going to write down what we're solving for down here. Cu, N, and O. The only one that I have a rule for is oxygen. Okay, that's it. I do not have a rule for copper. I know it's a metal, so it's only going to be positive, and most often it's 1 and 2 because that's what it says on your reference table. This, the BIC or IDE rule, like when it refers to the last element, oh, there's a lot of glare there. When it refers to the last, that was the sheet that I gave you yesterday. When it refers to that last element, okay, the IDE rule. Okay, we can't apply that here because it's ternary. There's three things. So I don't have a rule for Cu. I don't have a rule for N. There are two ways that we can come up with this. I can figure out Cu because NO3 is a polyatomic ion, and I can look that up. Remember, it's on reference table E. And since I know NO3 is a polyatomic ion, I can figure out what Cu is. This whole NO3 group, remember we count those as groups, this whole NO3 group is -1, and there's two of them. So what must copper be? Copper then has to be +2. You can work it out that way. We can figure out what copper is. Copper's +2. And now that we know what copper is, we're only left with N. Just we got to realize that there are two N's. So O is -2. Copper is +2. Now we have 6 oxygens, right? 3 times 2 is 6 oxygens. Each oxygen is -2, so that's really -12 for all the oxygens. There's only one copper because the 2 is multiplying just the parentheses, right? So the copper is +2. If we're going to add to 0 like we're supposed to, that means the nitrogens have to be 10. But how many nitrogens are there? Think. 2 nitrogens, right? So that means each nitrogen is +5. So +2 plus 5 minus 2 in chemistry equals 0. Okay? So my answer for the nitrogen is +5. Because remember, the number that we use, the number that we're going to track, right? The numbers that we're going to provide as answers for these things are one atom within that structure. Okay, that takes care of those. Here's the next 4 I'd like you to try and do the same thing. Pause, and then I'll review them. These need you to pay attention to our hierarchy. Remember this. I didn't have any problems in the first set that required that hierarchy. Well, I guess the hydrogen and oxygen rules, but the first 3 weren't used. Okay, I'm going to give you that list. There's 4 of them this time. Put it up here so you can see them. Try and focus it. The first one is, I'll read them, H2SO4. I'll repeat, H2SO4. The next one is CaO2. The next one is MgH2. And the last one, right, it's the toughest of the batch. I always make the last one in the batch the most difficult. Na2S2O3. I'll repeat, Na2S2O3. And I'll tell you what the hardest one is in that last one. Right, the last one, you're going to get a charge for one of these 3 that are not lit. I'll tell you which one it is. It's going to be S, because S doesn't have a rule here. You have a rule for 2 of them. I'm not going to tell you which rules they are, but you know it's got to be Na and O. You're going to have rules, all right, for 2 of them. The one that you don't have a rule for, you do that one last. Remember, there's 2 of it, and you're not going to get one of the listed charges. Remember, we do get charges not listed. Okay, you're going to have 2 of those 3 problems here, the last 3 problems. You're going to get answers that don't have charges listed. All right, so once you have that written down, or put me on pause now, solve them, unpause, and continue. Come get your crickets. All right, hopefully by now you've unpaused, and I'm going to start solving the last set. First one, H2SO4. You have H, S, and O. H and O have rules. They're down kind of low, right? But they have rules, so they go +1, -2. This is 4 minus 2, so that's -8. This is 2 plus 1, so that's +2. That means I'm missing 6, right? So that's +6, +1, +6, -2. Good? CaO2. Okay. I'm going to ask the name of this one too. We're going to have to do C, A, and O. Remember, you got to check with your periodic table to figure out which groups these are in. Ca is in group 2. Second one on the list. That's +2. It has to add to 0. You've got 2 oxygens. So that's a -1. When oxygen is a -1, that's a peroxide. It's really O2 as a -2. Each O being -1. And if you go to your polyatomic ion table, reference table E, you're going to find that listed as one of the polyatomic ions. There's cyanide, peroxide, and hydroxide. Those are your 3 polyatomic ions that end in IDE. Okay, and I've mentioned them a couple of times. You should be familiar with them because they do come up often enough. Cyanide, peroxide, hydroxide. Okay, that's the first 2. Third one, MgH2. You have a rule for Mg because it's in group 2. You have a rule for H. Actually, no, you don't have a rule for H. That's the one that's going to change because Mg is stronger. We don't have a rule for H. That's +2. There's 2 H's. Each H is going to be -1. When H is a -1, remember it's a non-metal, it's going to be the second one or the last one. That's going to be an IDE rule. This is going to be called magnesium hydride. That's when we use hydride for hydrogen, when it's the -1 in the compound. Okay, and now that last one, I'm going to do it two ways. I'm going to work on it as a polyatomic ion, or calculate the polyatomic ion out. And I'm also going to calculate it straight across, because you do have two rules. You probably calculated it straight across because that was the way it would make sense. But let me do it. Na2S2O3. We have Na, S, and O. Remember, we have a rule for Na and a rule for O. Right? It's always the last one, whichever one is lowest or weakest or non-existent on our list, is the one that we're going to manipulate to make the charges work out the way we want them to. So Na is 1, O is -2. There's 3 of those, so that's -6. 2 of these, that's only +2. So how much is missing? +4. Let me put it underneath, right? It's +2. Ooh, mistake, Mr. Castle. We're supposed to write the charge of 1 +1 +2 for both. Okay, right? That should be written +1. I wrote +2. That's a mistake. 2 of them are +2. 3 of these are -6. So what we have missing really is +4. +2, +4, -6. That will equal 0. But there's 2 of these S's making the +4, right? So each S is +2. Okay, and then that's our answer, +2. And if you look on the periodic table at element 16, sulfur, you're going to see a +2. I do not believe is listed. I'm not looking at my reference table now. I don't even have them with me. I can get them out of the book, but trust me, it's not there. Well, actually, no, don't trust me. Look. I think it has a +4, a +6, and a -2. I think 3 charges are listed. So, go back and confirm that. But the other way I said that you can do this is by using the polyatomic ion. I'll explain that now. Okay, because I got a couple of minutes. I have my rule for Na, so I know Na is +1. I know O is -2. I just have to find sulfur. So instead of using the 3, I can just say, well, S2O3, this is thiosulfate. It's listed on your polyatomic ion table. Turn to the polyatomic ion table, table E, look up thiosulfate. I believe it's on the right side, about half to 2/3 of the way down or something like that. I don't exactly remember where it is, but it's on the right. You'll see it, thiosulfate, S2O3, and you're going to see that this polyatomic ion has a -2 charge. Right? Oxygen is -2, so that's -6. The whole thing has to add to -2. What other number could we have to make a -2 with a -6 already being there? And that would be +4. Again, there's 2 of them, so +2 each. So +2 and -2 is -2, considering you have one more oxygen than sulfur. Okay, that's all of them. Let me give you one more, an easy one. OF2. Remember your rules. Look at the third one down here. You should keep that list with you when you do this. Take quizzes and tests and keep it with you. I actually think I'm going to put another castle up for learning, having you do some redox ones. I'll make it a short one. I'll make it like a quiz instead of a test. Maybe 5 questions so you can do some practice and show me that you've learned it. I'll give you like 3 or 4 days to do it. Hopefully you'll do it the first day, but not everyone's on the same schedule, and I get it. All right. Fluorine has the rule. That's first. Oxygen has a rule, but the fluorine rule is stronger. So oxygen has to change. And yes, this is the case where oxygen turns out to be positive 2. All right. That's it for today. Stay inside, stay dry, and keep plugging along. Take it easy. Be well.